Okay, let us go ahead. Stop this point. This shaft, what we discussed, was the shaft in series. These two shafts were in series. Let us go to a case where the shafts are in parallel. For example, if I say this is the structure and this is supported like this, like this. If I keep any object like this, anything, some load, like this, isn't it? Isn't it? If this is a rigid body, if this is a rigid body, deformation. This is aluminum, steel, brass, copper. Deformation in aluminum is same as steel, same as copper, same as brass. But a total load, give me a moment. But a total load, total force is equal to sum of force of aluminum plus steel plus copper plus brass. Load is shared. What ratio we don't know, but there is a summation of all the loads shared by each and every column is equal to the total load. This is parallel combination. We have discussed that. Similarly, we go ahead. Uh, Problem is like this. A steel shaft and aluminum tube are connected to a fixed support and to a rigid disc as shown in figure. Outer one is the aluminum tube. This is aluminum tube. Okay. This is rigid disc. Aluminum tube is hollow. This is a hollow tube and a solid shaft. A solid. This is, let me write. This is aluminum and its diameter is 70. Outer diameter of the aluminum shaft is 76 mm. Thickness. This thickness is 8 mm and it consists inside this aluminum tube. There is a steel shaft of diameter 50 mm, of same length 50 mm. Length is same, is known as 500 mm. 500 mm. Okay. Now, if the initials determine the maximum torque which may be applied to the disc if the allowable shear stress is 120, determine the maximum torque T in T max we should find. T max is equal to how much? If the allowable shear stresses in steel is 120 and aluminum it's 70 MPa. Tau steel 120 MPa. If the allowable stresses are 120 MPa in steel and 70 MPa in aluminum. Take rigidity modulus of steel as 80 GPa, rigidity modulus of aluminum as 27 GPa. If this is the problem, straightforward we can go and solve this. We know that. We know when the problem is posed like this, we need to find the torque acting at this end. I will consider this as a torque T. This is the torque maximum torque T max, which is acting at this on this disk, which is acting on this disk T max. Okay, we need to find that. So how do we go ahead? When I say this, let us write the equilibrium equations. We know that theta aluminum must be equal to theta steel, angle of twist in steel must be equal to angle of twist in aluminum. Total torque is equal to torque in aluminum plus torque in steel. This I call as one, equation two. When I say theta, you can write directly theta is equal to TL by Gj of aluminum must be equal to TL by Gj of steel. Okay, T aluminum, T aluminum, which is equal to length is 500 by G steel, which is equal to 80 into 10 power 3 into pi into d power 4 aluminum diameter. We should find like this. Uh, Outer diameter of the aluminum tube is given as 76 mm and thickness he has given as, let me write here, this is a hollow aluminum tube in which one the outer diameter is given. Outer diameter he has given as 76 mm diameter. T naught is equal to 76 mm. Thickness he has given as 8 mm. 8 mm. Then what would be di? Di is this. Di is this. Di is this length, which is nothing but di is equal to d naught minus 2t, because this thickness and this thickness has to be subtracted from d naught. Okay, or di which is equal to 76 minus 16, or di is equal to 60 mm. Okay, you should not take di is equal to d naught minus t. This is d naught minus t, then it will be from year to from year to year, then according to the concept. But it's di minus 2t, this thickness minus this thickness and this thickness will give di. Okay. 80 into pi into d naught power 4, 76 power 4 minus di power 4, 60 power 4 by 32. I will take to the numerator into 32, which is equal to, before that, okay, it's 32, which is equal to, shall I write it here, which is equal to T steel into length is 500 mm by G of steel, how much? G of steel, G of aluminum is 27, G of aluminum is 27, okay, G of aluminum is 27 10 power 3, 80 into 10 power 3 into pi into d power 4, 50 power 4 into 32. Can you tell me T of aluminum in terms of T of steel? This is equal to, 500 into 32 can cancel on either sides. How much? How much do T? Mikala. T of aluminum is equal to how much? How much? Dhruti, Mikala, Raghavendra, Sugun, how much?
1.1017.
Yes, 1.101 T steel. Okay, off of forward system now. From the second equation, Tt is equal to T aluminum plus T steel. Tt total torque at maximum torque is equal to 1.101 T steel plus T steel plus T steel, which total torque is equal to 2.101 times T steel. Okay, this T steel. Now we have to find T steel. Okay, how do you go ahead? We'll use this equation. T by J is equal to tau by R is equal to G theta by L. R T is equal to tau into J by R. T, T steel is equal to tau into J by R of steel. Tau steel we know. Tau steel less than 120 MPa. 120 into J by R, which is nothing but shall I write pi into D power 4. Steel section diameter is 50 mm. Pi D power 4 by 32 into radius, it's 25 mm by 1, which is equal to 120 into pi into 50 power 4 by 32 into 25. Can you tell me what is T steel? Therefore, T steel is equal to how much? How much, Mekala?
2.94 into 10 power 6.
2.945 243 into 10 power 6 Newton mm. From this expression, T aluminum is equal to 1.1012. T aluminum is equal to 1.1012 T steel. Therefore, T aluminum will be equal to 3.244 into 10 power 6 Newton mm. Total torque, which is equal to 2.101 into T steel, 2.101 into T steel is equal to 2.101 into 2.945243 into 10 power 6. Can you tell me the total torque?
6.187 into 10 power 6.
Okay, 6.1899 into 10 power 6 Newton. By this, I have completed almost all varieties of problem. If you have any doubts, you can ask. This completes your portion. Any doubts?
No, sir.
Monday onwards, we'll start with buckling. Okay, beams and this one diffraction, I will give the notes. Okay, but you can go through. Should I stop at this point?
Yes, sir.
Thank you.
Thank you, sir.